Integers are whole numbers that go from negative infinity to positive infinity. You can compare integers using an inequality, which is a mathematical sentence that has a greater than or less than symbol. Now, here you can use a number line to compare integers. Of course, integers with large magnitudes, i.e. that are far from zero, whether positive or negative, a number line is not recommended for obvious reasons. So, let's compare negative 3 and negative 1. Well, negative 3 is more negative than negative 1. Therefore, negative 3 is smaller than negative 1. 2 is, well, positive, and negative 3 is negative, so 2 is greater than negative 3, but also 2 is more towards the right end, so more towards the positive side of the number line, and, well, that's kind of how you use number lines to compare numbers. Are they closer to the positive side or closer to the negative side? The ones closer to the positive side are bigger. Okay. You can tell that I'm not exactly a fan of number lines, especially not by this grade level, but, well, you gotta know that they still do use them around here. So, example 2, evaluate each expression. The magnitude or absolute value of negative 4. Well, how far is negative 4 from 0? Oh, you go back 4. So, the magnitude or absolute value of negative 4 is 4. The absolute value of negative 3 plus the absolute value of 6 is equal to 3 plus 6. So, because negative 3 is 3 away from 0, and 6 is 6 away from 0. Result, 9. Exercises. Replace each blank with greater than, less than, or equal to make a true sentence. Okay, 9 and negative 2. Well, 9 is positive and negative 2 is, well, negative. So positives are greater than negatives. That's a simple way to deal with this. Negative 6 and negative 6, well, they're equal. They're the same thing. 5 and negative 5, oh, well, positive bigger than negative. Negative 10 and 1, well, 1 is positive, negative 10 is negative, so yeah, positive greater than negative. Now evaluate each expression. 4, well, the magnitude of 4 plus the magnitude of 4. That's equal to 4 plus 4, which is equal to 8. The magnitude of negative 4, well, negative 4 is 4 away from 0, so 4, plus the magnitude of negative 3, that's 3 away from 0, so 4 plus 3 equals 7. The magnitude of negative 9, well, that's 9 away from 0, minus the magnitude of negative 6, well, that's 6 away from 0, so minus 6, 9 minus 6 is equal to 3. Magnitude of 11, that's 11. And the absolute value of negative 3, that's just 3. So 11 plus 3 is equal to 14. Adding integers. Well, if we're adding integers with the same sign, you add the absolute values. And if they're both positive, whoa, we start off going positive and we add more positive. What do you think happens? Well, of course it's going to be positive. If they're both negative, oh, we start off coming negative from 0 and then we go more negative. Yeah, it's going to be negative. So, find the sum negative 3 plus negative 4. So we went to negative 3 and then we go another negative 4. So that's negative 7. What happens if they have different signs? Well, you subtract their absolute values. In other words, they partially cancel each other out, or maybe entirely if they're like, I don't know, 5 plus negative 5. Yeah. The sum is positive if the positive integer has a bigger absolute value. In other words, if the positive you're adding is bigger than the negative part. You cancel a lot of it out, and then the remaining part is still positive. Or negative if the negative integer's absolute value is greater. Yeah, more negative plus less positive ends with you still on the negative side of 0. Like, you go negative a lot, you go positive a little bit, oh, that's still on the negative side. So find each sum. Negative 5 plus 4. Negative 5 plus 4. So you got rid of 4 units of space on the negative side. What happens? You have 1 left. So, that's negative 1. 6 plus negative 2. Well, you went 6 positive and 2 back. 6 forward, 2 back means you went 4 forward. Yeah, forward is positive by convention, just like up is positive by convention when you're talking about directions. Of course, here we're not, but you get the point. So 6 plus negative 2 gives us 4. All right, exercises. Find each sum. 9 plus negative 13. So positive 9 minus 13. That ends up pushing us to negative 4. Now 1 and negative 4. So 1 and then back 4 gives us, well, one of them cancels out. So we end up with negative 3. Negative 31 plus 17. What's 31 minus 17? 31 minus 17 is 14. So negative 14. Negative 3 plus negative 15, that's negative 18. Negative 11 plus 4, that's negative 7. Okay, 43 plus negative 37, well, that's literally 43 minus 37 if we open up the bracket. So, that's 6. Hopefully we are still familiar with this stuff from previous grades. Integer subtraction. If we are subtracting integers, we're adding its additive inverse. In other words, minus 5, like say a minus 5 is equal to a plus negative 5. Or b minus negative 2 is equal to b plus positive 2. My God. Why do we have to do this for the North American curriculum? It's so that we know what an additive inverse is. It's something that adds to the original number to equal 0. In other words, you flip the sign. So find each difference. 9 minus 17. So you start at positive 9 and you go 17 in the negative direction. So 9 cancels out, and then you end up with another 8, which means you get negative 8. Negative 7 minus 3 is negative 10. Because, well, okay, we could have rewritten these as adding the additive inverse, but it was kind of not necessary. We mostly see that sort of thing when it comes to subtracting a negative. Because we can also say that when we open up the brackets, the sign in front of the bracket multiplies into each term of the bracket. In that case, this is 4 plus 5. Because the negative cancels out with the negative in front of the 5. 4 plus 5 is equal to 9. Negative 6 minus negative 3 is equal to negative 6 plus 3. So, negative 3. Now, let's find each of these differences. Negative 13 minus 17. Well, we start at negative 13 and then we go minus 17. That's just going to send us to negative 30. Negative 11 minus negative 2. Well, that's equal to negative 11 plus 2. Because minus negative 2 just means plus 2. Like if you open up the bracket and multiply in, or if you go by the approach mentioned about the additive inverses. Negative 11 plus 2 is equal to negative 9. Negative 6 minus negative 9. Well, if you open up the bracket, you end up with negative 6 plus 9. So 9 minus 6 is equal to 3. Negative 16 minus negative 20. Opening up the bracket just gives you a plus 20. So negative 16 plus 20 means 4. Because it's the same as 20 plus negative 16, or just 20 minus 16. Negative 24 minus 8. Well, you start at negative 24 and then you go another negative 8. That means negative 32. 26 minus 49. Well, that's going to send you down to negative 23. Because 23 plus 26 equals 49. The number of units you had to go back. When you're multiplying integers with different signs, the product of a number of integers that have an even number of negative symbols is positive. And if it has an odd number of negative symbols, number of minuses, that's, if you have an even number of negatives, they will cancel each other out in pairs. If you have an odd number, there's always going to be one negative left over, not canceled out. Result negative. And even negatives result positive. So let's find some products. 4 times negative 3. Oh, there's one negative symbol. So the result is going to be negative. And it's 3 times 4, which is 12. Negative 8 times 5. Well, there's one negative symbol, so it's negative. And 5 times 8 is 40. The two integers with the same sign, the result is positive. But if you have more than 2 integers, you have to go with the, do we have pairs of negative symbols that cancel each other out? I.e., is the total number of negatives even? That determines the sign that you're looking for. Find each product. 6 times 6. Well, there's no negatives, so it's positive. 6 times 6 is 36. Negative 7 times negative 4. There's 2 negatives, so multiplied together it's positive. And 4 times 7 is 28. Now let's say we multiply 3 numbers together. 6 times negative 3 times negative 2. Well, there's 2 negative symbols, so they cancel out. You can even cross them out if you like. Like if you have 10 numbers multiplied together, crossing out pairs of negatives is a good way to keep track of what you're canceling out. So you have no negatives left after canceling. Therefore, the result is positive. So 2 times 3 times 6, well, that's 6 times 6, or 36. Now let's find some products. 5 times negative 17 is, well, it's negative because there's one negative symbol here. And 5 times 17 is 85. Negative 13 times negative 5. Well, there's two negatives, so they cancel out. 5 times 13 is 65. 6 times 11, there's no negatives, so nothing to cancel. 6 times 11 is 66. Negative 13 times 2, well, there's one negative sign. And 13 times 2 is 26. Negative 11 times 3 times negative 11, no, there's two negative signs, so they cancel out. And we're looking at 11 times 3. So 121 times 3 gives us 363. Negative 6 times negative 4 times negative 12. Well, okay, well, let's cancel some negatives. Oh, we have one negative left. So an odd number of negatives, so it's negative. Okay, fine. 4 times 6 is 24. And times 12. 12 times 12 is 144, so 24 times 12 must be 288. Okay, now what about if we divide? Dividing integers works the same as multiplying because, well, if you divide by something, you're multiplying by its reciprocal. So, if you have the same signs, you end up with an even number of negative symbols, which means that they cancel out when you divide. So you end up with a positive result. If you have different signs, well, if you only have two items and they have different signs, then that means you have one negative, one positive. And that means that you end up with a negative quotient because the negatives do not cancel out. There's only one of them. Let's do some examples. Find each quotient. 14 divided by 2. No negative symbols here, so it's positive, and it's equal to 7. Negative 15 divided by negative 5. Well, the negatives cancel out, so it's 15 divided by 5, which is 3. Okay, now let's say we have different signs. 36 divided by negative 4. Well, there's one negative sign, so it doesn't cancel. 36 divided by 4 is 9. Negative 42 divided by 6, well, there's one negative. And 42 divided by 6 gives us 7. So it's negative 7. Alright, let's do some exercises. Find each quotient. 50 divided by negative 5. Well, there's one negative symbol, so no canceling. So it's negative. And 50 divided by 5 is 10. Negative 60 divided by negative 12. Well, there are two negatives. They cancel each other. And we end up with 60 divided by 12, which means 5. 100 divided by negative 5, well, there's one negative symbol, so negative. And 100 divided by 5, 20. Negative 200 divided by negative 20, that's going to end up being, oh, the negatives cancel, so it's 200 divided by 20 equals 10. 36 divided by negative 4, well, you only have one negative symbol, so the result is negative. 36 divided by 4 is 9. Negative 150 divided by negative 25, the negatives cancel out, so 150 divided by 25 is 6. So yeah, just keep an eye out for the number of negative symbols. If it's even, then you end up with a positive result. Odd, you end up with a negative result for multiplication and division. Addition and subtraction are completely different things. The coordinate system, also known as the Cartesian grid, comes in 4 quadrants. These are numbered counterclockwise from the positive x-axis. 1, 2, 3, and 4 as shown in this diagram. Now you don't need to remember which coordinates are positive and which are negative. Why don't you need to remember this? It's because you can just resketch the coordinates and, well, as long as you remember how they're numbered, it's immediately obvious where your positive x, negative y, or negative x, negative y, and so on, coordinates will end up. Memorizing these bits just ends up taking up more memory space without actually providing you with any appreciable additional utility. So just remember that it's quadrant 1, 2, 3, 4, numbered counterclockwise from the positive x-axis, and that you can redraw it at any time if you need to. Now graph and label each point on a coordinate plane. Name the quadrant in which each point lies. M, negative 2, 2. Well, negative 2 on the x-axis. Regrettably, my equipment is absolutely horrendous with actual dots, so I have to use x's to mark the points. Now, n is at 3, negative 4, so 3, negative 4. N at 3, negative 4. Okay, now let's say we graph and label some more points on a coordinate plane. Name the quadrant in which each point is located. A, 2, 4. A is at 2, 4, so 2 on the x, and then 4 on the y, that's here. Now we look at the points we have. Do we have any other points close to 3 or 4-ish that have y values that are this high? No. Therefore, we can put our label right here. Okay, B, negative 1, 1. Negative 1 on the x and 1 on the y, so this is where B is. Around negative 1 to positive 1, do we have any points that are around this y value? No, so we can just put our label right here. Negative 1, 1. Okay, C is at 0, negative 5. Well, that's going to be 0 for x, and then negative 5 for y. That's down here. C, 0, negative 5. Okay, how about the next point? Oh, it's G, it's not D. How interesting. G is at negative 4, 4. Negative 4 and 4. Okay, so this is G. Are there any others around negative 3 or negative 4 who are this high up? No? Okay. G. Negative 4. 4. Because otherwise you kind of have to adjust the position of your label, lest you get in your own way. So H is at 2, negative 4. 2, negative 4. Okay. Move down a bit. H, 2, negative 4. Okay then, I is at 4, 3. It's pretty unusual to actually see I being used. 1, 2, 3, 4 along the x and 3 along the y, because usually I doesn't get used that much in math, just because it looks like a 1 depending on how you write. J is at negative 5, negative 2, so J is over here. Negative 5, negative 2. And K is at 3, negative 5. So positive 3 on the x, and then negative 5. That puts us down here. k is 3, -5. All right then. How many points have we done? We've done 8, and we had 8 points to label. Wonderful. Now, hopefully, this chapter was a good review of integer operations and also of plotting on a coordinate grid. So, that's it for this chapter. See you next chapter.